Hi, welcome to my video on one-sided limits. One-sided limit. A limit, one-sided means you're coming in from the left to the right. A limit from the right side. And when we do a limit from the right side, we write limit x approaches a, some number, from plus. Plus is the right side of a function f of x. I'm using f of x here because I have the graph in f of x. So in relation to this notation, this is the limit, the f of x, as x approaches 2 from the right side. So as x comes in to 2, x is 2 here. So as we come in, x is 5, 4, 3, 2. When x is 5, we're right here. When x is 4, we're right here. When x is 3, we're right here. So as we come in to 2 on the right side, really we're coming down this piece of graph to right here, and that's a 3. So the limit, the x value, as approaches 2 from the right side, is the y value that's on the graph. And let's look at a limit from the left side. And the limit from the left side is denoted by the limit as x approaches a from negative of the f of x. And the negative means you're approaching a from the left side. So if we take the f of x, this graph here, this function f of x, we're approaching it from the left side. We're going negative 4, negative 3, negative 2, negative 1, 0, 1, 2. So we're coming in this way. So as we come in here, so negative 1 is right here at, let's say, negative 3. 0 is somewhere between negative 2 and negative 3. 1 is here, let's say negative 2. So as we come in this way, we're on this piece of the graph. So we're approaching the y value. So as we come in this way, we're coming up here. So we're approaching y equals negative 1. So it's a left side and a right side, a limit. So let's look at some more examples. Let's look at the g of x. This is the g of x, and we're approaching x. We're approaching x as 1 on the plus side. That's the right side. So here's x on the right side, approaching 1. There's 1 right there. So as we come in, approaching 1 on the right side, the y value is at 3, is right here. At 2, it's here. And as we come along, then we're moving up this curve until we get to 2. And what's the limit of this function, g of x, as you approach 1 from the left side? So we're coming in from the left side here. So that means we're coming up this curve right to here, and we get 2 also. So the two of them are the same. Another example, the h of x. We have this graph. What's the limit of the h of x as x approaches 0 on the left side? So the left side is here. So as we approach 0 on this side, the y value is negative 1. And as we approach the h of x, as the limit x approaches 0 on the positive side, that's the right side of h of x. This is coming in, x is coming into 0 on the right side, and so the y value is 1. Okay, hopefully this is helping you understand the right side and left side of a limit. Now, another way to write it down is to look at a piecewise function. So in this piecewise function, we have x is greater than negative 1. We have 2x plus 1, which this is a linear, but the linear starts at where x is negative 1, but the negative 1 is not included on this. And at x is negative 1, when x is negative 1, y is 3. And here we have x is less than negative 1, so we're on this linear. And again, this point in negative 1 into this function, that point is not included. It's a hollow dot. So let's look at the graph and graph it. So -1. So if we take x is greater than -1 with 2x plus 1. And just to, one way is to look at a table of values. And we start with a -1. We start with -1. 2 times -1, -2 plus 1 is -1. Then we're greater than -1, so we put a 0. Put a 0 in here. 2 times 0 is 0. 0 plus 1 is 1. So it's a linear. So the linear is starting off at the point right here, -1, -1. So that's a hollow dot because we can't include it. And it's leaving and going when x is 0, y is 1. And if we continue with that from this point, it's going on. There's the linear, it's doing this. And another way to graph this, the y-intercept is 1, slope is 2 over 1, 2 over 1. So you rise 2 and run 1. Rise 2 and run to the right 1. So that represents this part. And this one, if x is -1, y is 3. X is -1, y is 3. 1 right here. So that point is included in the graph. And in this one, we have x is less than -1, and we're looking at -x minus 2. Again, a table of values will do it, or we can say it's a linear. I'll do the table of values first. So let's put a -1 in. And -1 right here gives me negative of a -1 is 1, and 1 minus 2 is -1. So it's starting at this point, but this point is not included. And so let's go with -2. Put a -2 in here. And -2, the negative of a -2 is 2. 2 minus 2 is 0. So that gives me this point here. So it's doing this. It's a negative slope. The slope is negative, so negative means it goes up to the left or it goes down to the right. But we can't go down here because we got to go to the left of -1. So there's the graph. And as you can see, let's look at, you can see that it's going positive here, negative here. Both of these have the same point, -1, -1, but that's a hollow dot. So what's the f of -1? The f of -1 is 3. And what's the limit of the f of x as it approaches -1 from the negative? That's the left side. So as we approach -1 from the left side, we're coming in here. As this comes in here, we're going to the y is -1. And as we approach it, f of x to -1 on the positive side. So x is coming in here on the positive side. So y is coming down here. As we get to -1 on the right side, we have y is -1. So again, a graph helps you see, but you can see that this point right here, -1 will give you a -1 for y, and a -1 here will give you a -1 for y. So both of these are starting at the point -1, -1, but that point is not included into this linear or this linear. Now we have another example of a square root. The p of x equals the square root of x minus 3. So I want to look at the domain and range of this function. And we have a square root, and we know, or should know, that x minus 3 has to be greater than or equal to 0 because we can't have a negative number. That means x is greater than or equal to, x minus 3 is greater than or equal to 0. We cannot have a negative underneath here. So it has to be greater than or equal to 0. which means x got to be greater than or equal to 3. So the x values start at 3. So if you look at the graph, if the x values are starting at 3, and this is the p of x or the y value, so we start at 3, you put 3 in here, you get a 0. Now, pick numbers that will give you perfect squares. Put a 4 in here. So when I put a 4 here, I get 4 minus 3 is 1, square root of 1 is 1. And let's take one more number. We'd like to have a 4. The square root of 4 is 2, so to get a 4 I need a 7. 7 minus 4, so we'll put a 7 here. 7 minus 3 is 4, square root of 4 is 2. This is a square root, so it's a half of a parabola. And so when x is 3, y is 0. We're allowed to have that point. X is 4, y is 1. X is 7, y is 2. So it's a half of a parabola going sideways. So there it is there. There's what it looks like. And range, the range here, you can see the y values. We started at 0, so when you put a 0 in here, y is 0. So the range is the y, or the p of x, y is greater than or equal to 0. And again, we're talking about x belongs to the real numbers. And this is y belongs to the real numbers. That's why I have the shading. So the range, the y values here start at 0 and go upward. Y is greater than or equal to 0 on the reals. So this is the graph. So what's the p of 3? The p of 3, put 3 in, we get a 0. So this starts at the point 3, 0. And what's the limit? This is the limit as x approaches 3 on the right side. So as x comes in on this side, right side, the graph is coming down here, so we get a 0. Now, notice that there's no points over here on this graph. So if we come in on the left side, we can't come in on the left side because if we put 2 in here, we get a -1. Square root of -1 is an imaginary number. So you put a 0 in here, you get -3, again as an imaginary number. So I can't come in on this side. So that means the limit as it approaches 3 on the negative side does not exist. DNT. Does not exist. So I just wanted to do a sample of that, a limit. Sometimes you can't come in on the left or right side. And this is a one we discussed previous when we looked at the rational roots, and we looked at conics, part of the conic, and we looked at the limits of, or should I say, we looked at the word I'm looking for here, pertaining to rational things like that. We can't have a negative underneath a root, so let's look at this several ways. That means 4 minus x squared is greater than or equal to 0. And let's switch this around. Negative x squared plus 4 is greater than or equal to 0. And that means if we multiply by a negative number, x squared minus 4 is less than or equal to 0. And this is factorable into x plus 2, x minus 2 less than or equal to 0. So what we have, if we think about it, we have a number line that x right here is -2. Oops, put -2 there. X here is 2. These are the values of x, which will give you 0. And in between that, we'll put a 0. So let's take a 3 on this side, a 1 here, -1 here, and a -3. Let's look at these numbers. Which one is going to get less than or equal to 0, equal to 0? So we can have equal to 0 at 2, and a -2 is equal to 0, solid dot. So less than is a negative. So we put 3 in here, we get positive. Put a 3 here, we get positive. This is put a 3 here, we get positive 5. We get a positive 1. So that's a positive. Put a 1 in here. A 1 here is positive. A 1 here is negative. So the product is negative. We could put 0 in, but we're in between these two now. So either one of these 0 will do, as well as 1 and negative 1. And if we put a 0 in, we get a positive, negative, we still get a negative. Put negative 1 in, we get a positive, negative, negative. Product's negative. What about negative 3? Negative 3 right here will give me negative 1. Negative 3 will give me negative 3. Product is positive. But we need it, so the answer is negative 2 less than or equal to x less than or equal to 2. Or on the interval side, it's negative 2 comma 2. A square brackets means it's closed. So the domain is these values. That's the domain, the values of x, which will work here. So we're in between negative 2 and 2. So we'll start here and we're going to here. But if we put 2 in here, 2 squared is 4. 4 minus 4 is 0. So that means y is 0. So we put 2 in, we get 0. We put negative 2 in. Negative 2 squared is 4. 4 minus 4, we get 0. If we put 0 in here, 0 is 0 squared is 0. 4 minus 0 is 4. Square root of 4 is 2. 0 gives you a 2. So we're going from 2 to a negative 2, and we're going up to 2 at 0 in between. So what does that look like? So the range goes from 0 up to 2. This is a plus. We got to be, it's going up, but we can only go up between these values. So that means the range is 0 less than or equal to y less than or equal to 2. And again, y belongs to the reals. So what do we really have? Well, we have this shape. Really, we have a half of a circle, the upper part. And let's go back to here. Y equals square root of 4 minus x squared. This is the positive one. There's also a negative one. The negative one would have been down here. So when I did the square root from, let's see where it came from. Let's square both sides. Y squared equals 4 minus x squared. So we squared a y, get y squared. We squared a root gone. So that means x squared plus y squared equals 4. So notice we have a circle whose center is 0, 0, and the radius r squared is equal to 4. So r is plus or minus 2. So r is 2. But this is the upper part, so that's why we're looking at, again, the upper part of a circle. The circle would have gone all the way around, but this is the upper part. So let's look at this answer these questions. The d of 2. Put a 2 in, you get 4, we get a 0. The d of 2 is a 0. The d of 0, 0 is here, we get a 2. The d of negative 2, put a negative 2 in, we get a 0. Now let's look at the limits in relation to this function. If we go, a negative 2 is here. So we're going to a negative 2 on the left side. Negative 2 on the left side does not exist. How about a negative 2 on the positive side? If we're going to negative 2 on this side, going positive side, we would get y is 0. What's the limit of the d of x as you approach 2 on the negative side? So here's 2 here. We're approaching 2 on the negative side. So we're coming in here. The y value is 0. And what about if we approach d of x from 2 on the positive side? approaching 2 on the positive side, can't do it. So it does not exist. So I thought that one would be interesting to look at the one-sided limit in relation to this half a circle. And again, squaring this and seeing where it came from, realize that I have a circle, the upper half, and the limits, then you can see how they work. And again, it brings us to the end of the video. If you like my video, click on the like button, click on the subscribe button. Visit my math website, excuse me, www.mathfullyexplained.com to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.